All right, so next up, we're going to take a look at the binary search technique. And we're going to be having 3 different variables here. We're going to have a start variable, an end variable, and then a mid variable. And these 3, so the mid is not originally going to be calculated until we start our first loop, but the start variable is going to once again start at the beginning. So we can put start here. And our end variable is going to be at the end. So we're going to have 3 and 2. And then when we do calculate our mid value, we're going to loop through. It doesn't start till the loop starts, but we'll just do it now. So the mid value between this is going to be 5. So mid is currently going to be equal to 5. So these are our 3 starting variables that we're going to have. If we look through the steps of this problem, we're going to first, as I said, find that midpoint, which we did right here, of the array. Step 2, if mid value is greater than the end value, the start is now mid plus 1. And the reason that it's mid plus 1 is because at the end, when we actually code this problem up, we're going to use our end value as our value that we're going to return. So that's why it has to be start plus 1, because we know that if in the situation that mid was greater than the end, that our solution is going to be on the right side, which is why we do it that way. Then we have step 3, which is otherwise the midpoint is now the end value. And then at the end, we're just going to return that end value. So let's loop through this problem. So at the start, we're going to have 3, 2, and 5. So because our mid value is greater than our end value, our start is going to move forward to that 1 right here. And what's going to happen is, once again, we're going to, because start and end don't equal each other yet, so as long as start is less than end, which it still is, we're able to continue our loop. So once again, we're going to find the midpoint, and because our midpoint is going to be, we'll actually switch these up too. So we're going to do, our start is now 1, our end is now 2, and when we use our midpoint formula, it's going to do a float downwards. So the midpoint between 1 and 2 is actually just going to be 1. So it would be 1.5, but because we're going to do floor division when we do our mid value calculation, it's going to go down to the 1 value. So our mid is now 1. Let's add in our loop 2 values. So we got 1, we got 2, and then our mid now is 1. This is going to lead to our step 3, which is otherwise the midpoint is now the end value. So everything is right here. Mid is now the end value, and because in our original array, or how we're going to write this a little bit later, the while loop that we're going to create is as long as start is less than end, then we can continue to loop through. But in this case, start and end are now in the same place, so we're not going to be able to loop anymore, so we're done. We're now just going to return our end value, which is 1. And we are done with our binary search. And as you can see, we only have 2 loops as opposed to our 2-pointer where we had to do 4 different loops. See how this is already faster, just 2 loops. It's because with log n, you're skipping over a lot of numbers. You're doing like a half of it over and over and over again. And that's what makes it a little bit quicker. That's why LeetCode looks for that solution. Okay, so next up, we're going to take a look at our binary search solution. So we're going to do find min, just like we did before. And this time we're going to set our variables once again at the beginning and end of our array, and we're going to be finding the midpoint between those two. So we're going to go start, end equals 0, and then length of nums minus 1. And how we're going to solve is we're going to do the same kind of style for looping, and I want you to think of binary search while start less than end, so kind of same thing because we have the 2 pointers once again at the start and the end. I want you to think about binary search kind of like you would 2-pointer, but it's like a faster 2-pointer. It's like 2-pointer on steroids. That's really what it is. It's quicker. It has the log n as opposed to the n, but as I've said before, it only works on a sorted array or a rotated sorted array. This will not work on an unsorted array, so don't use it to solve one of those. but this will work for this kind of situation. So we're going to use the same kind of idea while start is less than end. And then this is going to be how in pretty much any binary search type situation you want to find the midpoint. This is going to be your solution right here. This is it. This right here is very important to know. Just remember this line for when you're doing binary search. And this operator right here is known as the Floor division operator. And our midpoint is going to be 1 over to the left. So like if we had a number like 1, 2, 3, 4, our midpoint would be the 2. Instead of, because our real midpoint would be 2.5, but in the case of floor division, it's going to be 2. Next, we're going to check to see if the mid value is greater than the end value. So let me just code that up, and then I'll do a little bit more explanation. So nums mid greater than nums end. And the reason that we're going to do it this way is we want to figure out if we need to move our start up or our end backwards, depending on the rotated array pivot point. And in the case that our mid was greater than nums end, it means that we need to move our start value because our value that we're looking for is on the left side. So start is going to equal mid plus 1. And the reason it's going to be mid plus 1 is because our end value is actually going to be what we're going to return at the end. So we want to move 1 up from mid. If we don't do it that way, then it'll lead to complications later on. And I kind of showed that a little bit in the demonstration, but just know that it has to be start equals mid plus 1. Then we can do our else statement. And for our else, all we have to do is n equals mid. And that's what we're going to return at the end. Then after that, real easy, is we're just going to return nums end. And we're done. And that's the whole solution. And there is some other solutions that I saw with this approach that were just terribly complicated and long, and they weren't any faster. This solution right here will get you a 98% on LeetCode. And if it doesn't get you a 98% right away, just try it a couple times. It will get you like a really high percentage on LeetCode because it's really fast, and as I said, this is an O log n time. And as you can see, we get the same answers that we got before. So this solves our necessary edge cases, and this is the correct way that LeetCode wants you to do it.